So let me go ahead and tell you guys what the exam's going to be like. Similar to in the past, since we learned 4 different statistical tests, you probably won't be surprised that there will be 4 questions, okay? For each of those, I'll ask you a question about whether or not a post hoc is necessary, and then ask you to tell me what you would do just conceptually, but I'm not going to ask you to take the time to work out all of the post hocs for whichever questions are significant. So basically, at the end of each question, there will just be a spot that says, is a post hoc necessary, yes or no? If you say yes, then it'll say, okay, what would you do? And you would just say, like, if it was a significant interaction, you would say, I would plot the interaction and talk about what it showed. If it was a significant main effect, then you would say a post hoc is necessary if it has 3 levels or more. But if it only has 2 levels, you would say, no, a post hoc is not necessary because it only has 2 levels. So it would just be a conceptual response. Yeah, I guess that's all I want to say about that. Then after the and also on the problems, for some of them, I'll give you some of the like intermediary steps in terms of the problem solving. Like I might give you the sums of x squared, or I might give you sums of squares. That won't be true for all of them, but for some of the ones that get really complex, I'll give you some of the partial work, just really to save time. You will have a formula sheet. Hopefully you guys have already found that in the materials for exam number 3. You have the formula sheet to use, and it's laid out the way that I did when I did problem solving, where it's a source table with all of the little steps filled in terms of the formulas. And then the last part of the test will have just a few questions, not worth too many points, but a few questions about trying to judge if interactions or main effects are significant based on either a graph or having like the means within each of the cells. And then the last thing will be just to fill in one source table that is not complete. So a couple things I want to tell you. So I should have said this a second ago, but for the problems where you have to figure out if the main effects and interactions are likely to be significant, I made what did I make? I made like a video, right, where I sort of worked through it in an Excel database, sort of showing you. No, wait, I'm getting ahead of myself. I'm sorry. For the main effects and interactions, there's a PowerPoint available in that last week where it's like a review. I'm going to go over real quick and see if I can see it. Hold on a second. See if I can tell you what the name of it is. Hold on one second. It's in week 16, and it says practice picking the test and identifying main effects and interactions for exam. It's a PowerPoint that's available in week 16. So that's where you can get some practice with that. And then I had previously put up that solving source tables. Oh man, where is that? I might have to email you and tell you where it is. But I sent you guys an announcement and put a new little chat up there that was like a solving the source tables chat. I can't see it right now. So I'll send you an email and let you know where that is. Unless anybody else knows where that is. I stuck it somewhere. I can't remember where I stuck it, but I sent it to you at an announcement, so you should have a link to it. Sorry?
I looked at it yesterday, and I found it through the announcement. I just went back on it.
You found it from the announcement, Abby?
Yeah.
Okay, perfect. So if you guys can look back at the announcement, maybe I didn't stick it anywhere because I didn't know where to put it. I'll put it, if it's not already there, I'll put it under week 16 as well, because it's basically kind of a review for the exam. I think that's it. Any questions about the exam itself? Okay, Lisa, you got a question queued up for us?
Yeah, just on the formula table for the exam for the repeated measures ANOVA, or the DF error formula, the formula says n minus k minus n plus 1.
Right.
But should it be -1? What is the formula for repeated measures DF error?
Yeah, so if you're looking at it, Lisa, see where it says the degrees of freedom for within treatments. That's big N minus K.
Mm-hmm.
And then the degrees of freedom between subjects is little n minus 1.
Mm-hmm.
Well, if you subtract the degrees of freedom between subjects from the degrees of freedom within treatments, that will give you the degrees of freedom error. So it's literally just taking that big N minus K minus, and then you would put in parentheses, minus little n minus 1. So when you get rid of the parentheses, that means it's big N minus K minus little n plus 1 because you changed the sign.
Oh, okay.
So those two, the between subjects degrees of freedom and the error degrees of freedom, total, if you add those together, that will give you the degrees of freedom within treatments.
Okay. Okay.
Does that make sense?
Yeah.
Okay. Uh-oh. Oh, geez, hold on. Okay. Anybody else have a question? I've got some people sent in if you guys don't. One of the questions I got from one of your classmates was, you know, in the past, I've sort of talked about ways that you might use experimental design to increase your likelihood of finding a statistically significant result. And what's really cool, and I hope you guys can appreciate how cool this is that every statistical test that we've learned this whole semester has had essentially the same formula. There's a numerator over a denominator. The numerator is always, for every test we've learned, going all the way back to z-test, the numerator is always the variance that we think we can explain from the independent variable that we're looking at. So when we think about a t-test, it was easy because it's basically like an independent samples t-test. It's the difference between our treatment mean and our comparison mean, or our control group mean. And so that's the variance we think we can explain. When we're talking about ANOVAs, the variance that goes in the numerator is the between treatment variance. So it's how different is the mean of each treatment group from basically the overall average. What goes in the denominator is always, for every test we've learned, the unexplained variance. So it is the variability between people or between subjects that we can't explain. And so when you're thinking about trying to maximize your likelihood of finding a statistically significant result, which is the same thing as saying increase your power, the way you would do it for all tests that we use is essentially the same. And that is, we would try to maximize the effectiveness of the treatment. We would try to maximize the difference between our comparison groups. So we would give sort of the biggest dose of the independent variable that we thought made sense to give. At the same time, we would try to minimize the variance that's in the denominator. And so to do that, we would try to get a pretty homogeneous sample. We might limit our sample to one sex, for instance, or we might put a tight age restriction on the participants. And the reason we're doing that is because we want those people to be as alike as they possibly can. The even bigger way that we would do that would be to use a within subjects or repeated measures design. So if we are comparing people to themselves, then clearly we've taken out that individual variability to an extent. We've gotten rid of a big piece of that variance. And so when you think about a repeated measures ANOVA, that extra subtraction that you get to do of variance from the denominator dramatically increases the size of your F in a way that's going to increase your likelihood of finding significance. Does that make sense to you guys? Anybody have any head nods? One way or the other, yes or no? So, I mean, to me, that's one of the really coolest things about statistics in general is that all of the tests are doing the same thing. It's just that you need to use specific tests depending upon the specific design of the question you're trying to answer. And so that's another question that somebody had sent in was to talk a little bit about how you pick the test. Now, if you look at that PowerPoint that I was just talking about, I think it's the very first slide that has a little flow chart that might help you to kind of think about that. And there's different ways to sort of walk through the steps of how you figure out which statistical tool you need to use. But the design of your study does mandate the specific statistical test you should be using. So for instance, if the independent variable, the variable that you think is causing the difference or the change, is a continuous variable, then we have to use regression. That's our only tool that we have right now to analyze that design. Our dependent variables are always continuous, right? For this class, we have only looked at continuous dependent variables. We have not looked at any kind of binary or categorical dependent variables. You'd have to get that in a separate class. But that's because usually the designs you guys will be seeing or the experiments you might be conducting, typically you're going to be measuring a continuous dependent variable. So all you need to do to figure out the tool that you need to use is to look at the independent variable. If the independent variable is continuous, then you have to use regression. If the independent variable is categorical, then you're either going to be using a t-test or an ANOVA. If there are only two levels of the independent variable, then you can use t-test or ANOVA. You'll get the same, you'll draw the same conclusion. You won't get the same result because a t is not the same as an f, but you'll draw the same conclusion. If there are 3 levels or more, then you have to use ANOVA, right? Which is what we've been working on in this last unit. Now, the only other questions are, okay, maybe should have started here, but is there a second independent variable? If there's a second independent variable, like I'm looking at sex and age, right? If there's 2 independent variables, then it's pretty obvious, right? I'll be using a 2-way analysis of variance. If there's only 1 independent variable, then my next question is that independent variable a within subjects or repeated measures variable, meaning that I have the same people in each condition, or is it a between subjects variable so that it's different people in level A and different people in level B? They're not the same folks. And that's the distinction that you use to decide if you're doing a repeated measures ANOVA or a between subjects ANOVA. So I think that's, in some ways, I know that's a hard part for you guys. I hope that you all took advantage of those discussion boards. If you haven't previously, I'd encourage you to look at those again, because that's where you guys were trying to think about, okay, questions I'm interested in answering. Here's a question I'm interested in answering that I think would require a one-way ANOVA. And so that gives you just exposure to additional designs and research questions that can help you to think about, how do I figure this out? The PowerPoint that I mentioned has several practice ones, and obviously you can use the worksheets previously as a way to also practice that. Again, I don't know if anybody's done this before, but a good way to practice would be to take all of the worksheets we've used in this unit, cut them into little pieces, on the back write down which design it was before you mix them all up, and then mix them all up and almost use it like flashcards. Read a question, what design do I think, or what statistical tool do I think this requires, and then just check on the back. So that would be a way to get some additional practice with that as well. Let's see, I think there were 2 other questions I got. One question was about multiple regression. The textbook gives you a really nice introduction to what multiple regression is, and that is a tool that you will really be likely to see in the literature, because we often are using more than one independent variable or predictor, not just one. But I'm not going to test you on that, and so that's not something you need to spend time on preparing for the exam. If anybody as an individual wants to talk more about multiple regression, I'd be happy to do that. But I think I'd just do that on an individual basis, because that's not something you're going to be held responsible for. The last thing I think I want to say, and then I'll, again, hopefully maybe have triggered some questions from you guys, is when you're thinking about a 2-way analysis of variance, that means there are 2 independent variables. Either of those independent variables could be significant, which would be called a significant main effect, and or the interaction could be significant. The interaction means that the effect of one variable is influenced by the other variable. Let me say that one more time, maybe more explicitly. The effects of one independent variable are influenced by the levels of the other independent variable. When you do a 2-way analysis of variance, you could have any possible combination of significant and non-significant effects. So you could have one significant main effect and nothing else, both main effects significant, no interaction, just the interaction, no main effects, one main effect, the interaction, and not the other main effect, or all three. So anything is truly possible. When you have a significant main effect, that means if I ignore the second independent variable, if I ignore that variable, then the levels of that first independent variable I'm talking about have a significant impact on the results. If I have a significant main effect for the other independent variable, it's the same thing. That means I have a significant main effect for that factor if it's factor B when I ignore factor A. And the interaction one is the one that's tricky. It is the effects of factor A differ depending on the level of factor B. So it could be that factor A, level 1, I see an impact. It could be that factor A has an impact at level 1 of B, but no impact at level 2. Or it has a positive impact at level 1 of factor B, but a negative impact at level 2. It could be anything like that. It could just differ in the magnitude of the effect. So maybe the effect of level A, whatever that variable is, at level 1 of B is like 10. It makes a 10-point difference, but at level 2 it makes a 20-point difference. That could still be a significant interaction because the magnitude of the effect is different. Does that make sense to you guys? It's maybe hard because I'm talking in the abstract. The place that I see it a lot in my research is that when we test younger adults and we have them do a single session of acute exercise, if I measure their cognitive performance pre and post exercise, acute exercise has a small benefit for young adults. But if I do that same experiment with older adults, I get a big benefit. So if I do a study where I include young and old, and that's an independent variable, and I measure them pre and post exercise, that's my other independent variable, what I find is that the difference from pre to post for the young people is not as big as the difference from pre to post for the older people. And that would be a significant interaction. Does that make sense? That would also probably be a significant main effect for exercise because both groups improved in response to exercise. So if I ignore age, both groups improve in response to exercise. It would only be a main effect for age if people were performing differently on average based on their age group. So if my older people also were not as good at the cognitive task as the younger people, which is often the case, then I would probably also get a main effect for age. Because when I ignore exercise, the younger people perform better than the older people. Does that help you guys with the interactions? So what questions do you guys have? That means you guys are ready to go, right? Everybody's going to knock this one out of the park. End on a high note. Okay, well, those are all the questions that I got in advance. There's a lot of practice opportunities out there. There's a worksheet for the exam. There's the PowerPoint that I've mentioned a couple times. I'll make sure to put that video for completing the source tables in that final week, in that week 16 unit. You've got a whole week to take the exam, so take it whenever is best for you, whenever you feel ready. And then make sure that you also are prepared to get that SPSS assignment done if you haven't done already. Oh, okay, good. Somebody just sent in a question. Yeah, so the question is, how do you tell main effects and interactions from a line graph? And if you look at that PowerPoint, it'll really help because I give you some examples. Hang on, I'm gonna grab a piece of scratch paper. All right, give me a second. I'm not prepared. If you were, can you guys see that? If that was the graph that you were given and I asked you to tell me about main effects and interactions, you're probably thinking, whoa, how can I even do that? I don't know what's what. There's no y-axis, there's no x-axis. Well, actually, if that is showing sort of a two-level factor A and a two-level factor B, then I can add some information to that. So I can just say, okay, here's where B1 is and B2, and there's A1 and A2, right? Now, looking at that graph, you can guess that there might be a main effect for factor A, because when people are in condition A2 or level A2, they score better or higher. I don't know if it's better, but they score higher than when they're in level A1. So there's probably a main effect for A. The way that you can figure that out if you want to draw on it is, hold on. Oops. Oh, I made a mistake. This is why I can't do things live. You guys are lucky I do everything ahead of time. Hold on. If I were to calculate the average for A1 and the average for A2, it would be somewhere between those values, right? So if I ignore B, then you can see that the average for A2 is always above the average for A1. Now, if I wanted to look at the B's and ignore A, I would just figure out what the average is for B1 ignoring A and the average for B2 ignoring A. And because that line that I sort of drew in the middle goes up, I would guess that there's a main effect for B. Does that make sense? And then the way that you know that whether there's an interaction or not is just to say if the lines are parallel. Because the lines are parallel, that means there's no interaction. Okay, let me show another one where there is an interaction. There's one on the right now where there is an interaction because the lines aren't parallel, right? Now, whether or not there's a main effect for B and a main effect for A, you have to sort of do some calculations. You can add in fake numbers if that helps you, if that's easier than just doing it spatially the way I was showing. So if I add in some fake numbers, I just added in some fake numbers. So then I would just get the averages for like for B1, I would get the average of the A1 value and the A2 value, and then I'd get the average for B2 of the A1 value and the A2 value. So that would be, let's see, B2 average equals 40 and divided by 2 equals 5. Okay, so down at the bottom, I sort of wrote in how I would do it for B. So if I'm kind of putting in those estimates, there's actually 2 dots there at B1. I hope you guys can figure that out. A1 and A2 are in the same spot. They're both at the value of 10. So to get the average for B1, I just say 10 plus 10 divided by 2. That average is 10. To get the average for B2, I take 10 plus 40, gives me 50 divided by 2. That's 25. So it looks like there'd be a main effect for B, because at B1, the average is 10. At B2, the average is 25. And then for A, I would do a similar thing. So if I want to average the A1 average, be 10 plus 10 divided by 2 is 10. The A2 average is 10 plus 40 divided by 2. It sort of comes out the same, which probably makes this not a good example, because you guys might have a harder time seeing what I'm doing. And this is, when I show it on the screen, it's backwards for me. So, okay, so A1, the average I'm just taking, this is line A1. So the A1 point at B2 is 10. The A1 point at B1 is 10. So for A1, the average is the average of 10 plus 10. So that's, am I looking at it? That's 10. And then for A2, it's the same thing. The A2 point at B2 is 40. The A2 point at B1 is 10. So I'm going to get the average of these two, and that gives me 25. So there's probably a main effect for A. And then because the lines aren't parallel, there's probably an interaction. I like doing it with the numbers. It's harder for me to do it this way, but some people are spatial and that works. But I like doing it better with the numbers. And I gave you, in that PowerPoint, there's some more examples of that with some of those variables having 3 levels instead of just 2 levels.
So we did something similar to that, like with a table and the numbers, like A's at the top, B's down the side.
That's
And
right.
the numbers are in. And if it's 0, that means there's not an interaction, right? If we were getting zeros between the two, I don't have it in front of me, so I'm trying to think back to it.
Yeah,
But we can basically take the graph and make our own chart, couldn't we?
that's right. I mean,
Okay.
the interaction to me is much easier to see from the figure. So
Right.
if I gave it to you in a table, I would go ahead and graph it, and then it's easier to judge that from the figure for sure. But hang on one second. I guess I could have gotten more than one piece of paper. Hang on. Let me just try to do the one that I just did a second ago. And 1, 2. Okay. This is the one that I just drew a second ago that we were just looking at. And so the numbers in the cells only tell me about the interaction. And from that, you can see, I think you can see, right, that if you go from level B1 to B2 here at level A1, there's no change. But here, there's a change of 30. So that means that the impact of B on whatever we're measuring differs as a function of what level of A we're at, right? At level A1, there's no difference. But at level A2, variable B makes a big difference. So that's exactly what a significant interaction is. And then, just like I was doing from the graph, you would get the averages for B1 and the average for B2, which essentially is what I was saying, right? I said a main effect means you ignore the other variable. So the average for B1, and this is assuming that there's equal sample size, of course. The average for B1 is 10 and the average for B2 is 25, suggesting that there's a main effect for B. And then I would do the same thing for A1 and A2. So I think graphing, if you were given this data, I think graphing the cells is the easiest way to see the interaction. But then calculating these averages for the main effects is probably the easiest way to see the main effects.
And so if the average is the same between like B1 and B2, there isn't a main effect.
Yeah, that's exactly
Okay.
right.
Okay.
That's exactly right, Leah. If the average is the same, then that means there's no main effect.
Thanks.
Yeah, you're welcome. Other questions? So let me just say something about that real quick. Two-way analysis of variance is kind of where it's at. Like that's where we want to be. That's the kind of work that we often do because I'm not typically only interested in one independent variable at a time. I'm often interested in a couple of different things. So I know it's an easy example I keep giving, but maybe I'm interested in age and sex, and the combined influence of those two variables is what is tested by the interaction. And that's what I get most excited about. If I don't measure age, if I just get a huge population of people and I have some younger people and some older people, the benefits of exercise that I was just describing might not show up. because they're pretty small for the young people. So what if I do a study where I recruit this? I do this all the time at UNCG, right? I recruit from campus, and I end up getting 40 people who are college-aged undergrads, but then I get a handful of faculty members or staff members on campus who agree to participate. Well, when I run the study, if I only look at the beneficial effects or what I'm looking for, what I'm expecting, beneficial effects of acute exercise on cognition, I might not get anything because people are really different. All that variance between people goes in the denominator. But if I know that age might be important, and so I divide the group also into age groups, then all of a sudden I go, wow, I got a huge effect for the older people. It was overshadowed by the really small effect I got for the young people. So adding that second variable makes an important difference in my understanding of the question I'm trying to ask and answer. So when you guys are thinking about your own research, it may be that there is only one variable that you're interested in, but you always want to kind of keep your eye out for other variables that might be explaining a significant amount of the variance, and that if you include it in your design, would be able to help you to really tease apart a meaningful effect that you might not otherwise see. So I know it's hard. You guys are focused on solving the problems, but try to also think conceptually about why we're doing this, why it's important, why we're adding this second variable. It's not just to make life hard for you guys. It's because it can help us to really explain and answer our questions better. Okay, any other questions? Well, I have no phone until I get my hard drive back and Telephone Services comes back and gives me a phone. But I'll be on email. My hard drive died. I guess you guys didn't all hear that. You should all be crying for me right now. My hard drive died. I'm working on my laptop. I have email, but I won't be accessible by phone for another day or two. But if you need me, obviously reach out with an email and I'll be happy to talk to you. But otherwise, you guys just do your best to prepare. You've done a great job all semester. I know you'll do well on this last exam. And just don't let the SPSS assignment sneak up on you. Make sure you get that done as well. And I hope you do well on everything else you have left this exam. And I guess that's it.
Thank you.
Okay. Thanks, you guys. Have a great day.
Thank you.
you.
Bye.
Thank you.
Thanks.